Okay.
All right.
Can you go back to the puzzle part one more time, please?
Okay, so yeah, there is nothing much on the slide as such, so I'll bring it up. Before any new block can be added, every computer has to put in the effort to solve a particular puzzle. All right, and I'll go into the details of why that has to be done and how it is done, right? But in simple terms, let me put it this way, and I think I'll jump to it right away, though it was not essentially in this order, but it doesn't matter. I introduce a new block, a new set of transactions, right? A block is formed, okay?
If Mohammed is selling the pen to Lata, is that a new block or is it a transaction?
It's a transaction, it's not a, but series of transactions will come together and form a block, right? And the transaction can come from different computers, doesn't matter, right? Frankly, as far as the system is concerned, since everything is traced because of the hash references and so on and so forth, it doesn't matter that only his transactions have to come together in one block. There can be multiple transactions that can sit and it becomes one block, right? So a new block gets introduced, right? And once the new block gets introduced, that information is sent to all the nodes, right, or computers connected to blockchain, okay? And then all the computers start the process of validating that information. Okay, so what do they validate? All the things that we talked right up front. Whether the owner, right, is he the right owner, right? The series of transactions, checking that yes, there is his consent that he wants to sell it, the identification of the receiver, all those things that we talked about, right? That is part of the validation that has to happen, right? And all the nodes start working, all the nodes that are active, right, they start working on validating it, right? As they validate the block, right, then in parallel, this puzzle has to be solved along with it, okay? And that's the effort that is required. Once I say I have validated the block, I share that information to every other node. Now, none of us are actively doing anything, right? This is all happening in the computer world and the systems are participating. That information is sent to all the nodes that the puzzle has been solved and the block has been validated. Once that happens, all other computers, they stop validating that block and they start verifying whether the validation has been done right, and once they validate that yes, this has been done right, they will add it to their version of the ledger. Now, it might happen that the first transaction that came to you, you added to your ledger, right? But the second one, right, which was an incorrect one, I'm talking about a fraudulent situation here, right? And that data also, right, comes to you, but by then your ledger has moved on, right? Because your version of the ledger keeps on adding data. But somebody else, right, is adding, may not have received your version of the ledger or may not have validated the block. They would probably see a different version, right? And once that version comes to you and your system reconciles, at that point in time, right, it will start seeing that, hey, your version had the transaction which originated later, the version that came to you has a transaction which originated earlier, and that is the right version, and you will probably add that branch to your ledger, right, and take that as the real one. So that's why, and what is happening here, that even though this information is being spread without any central control, each computer in one form or the other is validating which of the two transactions is the real one, right? And when more than 51% or 50% or 51% of the computers in the system have acknowledged, accepted that yes, this is the right version and this is not, then at that point in time, that becomes the dominant version, the consistent version. That's why when you talk about blockchain, the term that you will hear out there is eventually consistent, right? So initially, because you have a set of computers which are faster, better, or whatever, or closer, or better connected, or whatever, I don't know, you might be able to spread the information in the wrong manner, right? But as long as you don't control 51% of the computers or the nodes in the system, right? Eventually, the true version will evolve, right? So that's why it is, even though there is no central authority, the computers solve that problem by themselves.
Two questions. Is there a valid authenticated time, centrally authenticated time server so that everybody agrees on the correct source of the timestamps?
That is the blockchain algorithm, the blockchain consortium, right? They set it up. That
okay.
there is, and this is a question that has been answered. They have taken care of this.
Okay. Then the next question, is there a time limit on the latency for getting consensus on which transaction is the correct one?
I don't know that. Yeah. When they say eventually consistent, yeah, I don't know what is that.
Because the more copies you have, the longer it's going to take.
I agree. And I don't have an answer because I'm not a practitioner to that effect.
Okay.
I used it, right, for my company. So we basically applied it to my software product, and I'll describe how we used it.
Mm-hmm.
But I don't think we got to that level of sophistication.
Okay.
Right?
So just to verify my understanding, are you saying that every node has a copy of every block?
Every node has the copy of the entire ledger.
Which means every block?
Yeah, that's right.
And that's where the complexity is introduced, and predicting that the blockchain will eventually use a lot of computer times, and it may also use a lot of energy of various nodes, and hence it becomes a little bit prohibitive in practice.
No, I disagree, because the growth of computers is exponential and the power distribution of the computers is going down. So
Yeah, I mean,
the
this
computers
is-
are heading
this is
are
a
keeping up
prediction.
just as fast.
Unless we come to the plasma computing, things like that.
Yeah, no.
The computation
Still
is-
keeping up just as fast as the
No.
complexity.
At least whatever I know is different from what you just said. Each Bitcoin transaction consumes 250 kilowatt hour, enough to power an average home for 9 days. Alright. Some predictions are, if it continues at the same pace, by 2020, so at this point in time, the limited blockchain usability consumes globally as much electricity as the country of Denmark. At this pace, or this was 2 years back, if it continues the same pace, by this time it will consume as much electricity as the entire world does today. So that's why you see those huge energy. So most of these big, I think, computer farms are located next to power sources. That's one. But this is not tenable. So what is being done is the burden of proof is being shifted from that effort that is going towards mining, right, to burden of stake. Right, so proof of work to proof of stake. That's a new concept that is being practiced as we speak.
Sorry, so what happens if one server goes down completely?
It doesn't matter.
Yeah.
Because these are all interrelated.
Yes, so it doesn't matter, right?
It's a copy is there.
It's like,
Oh, never mind.
it doesn't even matter, right? And in case if all of us have that information and we keep talking and spreading, even if you walk out, sorry to put it that way, it doesn't matter if you walk out.
I understood that creating a new Bitcoin requires a lot of energy. But are you saying each Bitcoin transaction requires that much energy?
Eventually, right? Because everybody works towards validating the block.
Yeah.
You mean I buy something from a store and pay for it with Bitcoin, I need to
Can I say something?
Sure.
Yeah, I am a practitioner of blockchain actually. I'll not go into the details. We are implementing for the whole finance industry some blockchain application.
Could you please speak
No.
a little louder?
Okay,
Can you?
let me stand.
Yeah.
Yeah. So we are putting some blockchain application for the whole finance industry. What you said is correct. And what you mentioned, that's actually the crux of it. We are going from effort to stake. That is number one, to reduce the burden. Second thing is that there are two groups. You mentioned that miners. So what we tell them, one are validators, one are observers. So when the miner is validator, that means if I want to earn Bitcoin, then I am a validator. That is the time I need that kind of power and energy to compute. If I am observer, then I do not need that because I am just transacting. So that means I just get a copy, and copy is not the whole amount of data, it's the hash. So it's not too much of a data. That's how it is being managed. So if I am just an observer node where I am transacting, I am doing a Bitcoin transactions with you, it's not a problem. If I am trying to mine and earn Bitcoin, that is the time I need a power. So that's the difference I just wanted
So
to
within a network, some people will want to participate in the generating of that.
Can you stay standing?
You are getting the hash of multiple transactions, isn't it? Not only
No,
single transaction.
Not
you
a
are
single
getting data
transaction,
from multiple
it is a
transactions.
block of transactions, goes in a half an hour or an hour, that kind of.
Or we give a time.
Yeah.
See that, we can continue. We can continue, looks like nobody